Standard MGSE 9 through 12 G.MG.2 apply concepts of density based on area and volume in modeling situations. Examples that could be used to build understanding of this standard are population density, such as the number of people per square mile or the number of ants per square inch. Energy guide labels, which provide energy consumption and cost information for consumer products, could also be used, as they provide a measure of energy, a BTU per cubic foot. In this video, students will begin their journey with this standard with a question from the 101 Questions website. We'll also engage students in NCTM's 5 practices for orchestrating productive mathematical discussions, as featured in the book by Mary K. Stein and Margaret Swan Smith. The 5 practices of anticipating, monitoring, selecting, sequencing, and connecting will help guide students to more productive discussions in their mathematics classes. For more information about these strategies, please check out the free PDF version of this book at the link provided in the listing of resources for this video. The listed resources also include a sample planning sheet, which provides teachers a framework as they begin implementing the 5 strategies. In the following clips, students are engaged in the 3-act task, Apple's Mothership Office. This task provides a unique learning opportunity for students. It invites curiosity as students investigate several questions generated by their class in which the concepts of area, density, and proportional reasoning are applied. The task can be found on the 101 Questions website and was originally featured by Dan Meyer. A 3-act task is a whole group mathematics task consisting of 3 distinct parts: an engaging and perplexing Act 1, an information and solution seeking Act 2, and a solution discussing and solution revealing Act 3. More information on 3-act task can be found in the Effective Instructional Practices Guide, which is provided in the listing of resources for this video. In Act 1, students will watch a video as the late Steve Jobs introduces his concept for the Apple office compound.
And what we've done is we've bought this land right here. And the campus we'd like to build there is one building that holds 12,000 people. It's a little like a spaceship landed. But there it is. It's a circle.
After students have a chance to watch the video, give them a little time to think and wonder. What do you notice? What do you wonder about this office complex?
What it is. How big it is?
Okay, how big it is. It said about how many employees it's supposed to hold?
12,000.
If you could guess, how much room do you think each employee would take up? Well, how big would that office be?
At least 8 by 8, maybe.
Yeah, 8 by
8 by
8. That should be good.
Yeah, that'd be decent.
As students dive into Act 2, they'll be provided with more information based on the questions that they decide to investigate. This class has decided to investigate how much office space a worker would get based on the space available in the compound as well as the number of workers Mr. Jobs has announced there would be inside the office space.
Let's determine with taping on the floor, as we'll come up, determine how much space an employee should need to work. How many square feet do you think an employee should get?
At least an 8 by 8.
Because this is supposed to house 12,000 employees.
How much is that?
Yeah, it's a foot. Should be a foot. It's a 12 by 12 tile.
Do an 8 by 8.
Hold up,
Okay.
All right.
I said about 4 or 5.
4 stories?
I say about 11 by 11.
All right. For us to actually know exactly how many stories, what would we need?
The height,
The blueprint.
to know exactly.
Blueprints.
Oh.
Let's see if I have some blueprints.
Both groups have made their estimate for the size of the office space they will allow their employees and have begun to analyze the blueprints to finalize the amount of office space available.
Do we have 1 second?
I don't know
too, because there's one in the middle and there's one on the outside.
Okay, so this one, 460 is which one?
The bigger one on
The
the
bigger
outside.
one, and then the 322 is
The inside.
the inside. He's just gonna have a landscape in the inside.
Wait, so
That's a waste of space.
all that is not nothing.
It's gonna be
That's just a
landscape,
waste
it's
of-
gonna be trees.
Space.
You could differentiate this task for your students based on the type of blueprint that you provide to them for the task. Some students could be provided the entire blueprint packet, as was the case in this class, or you could provide the one-page guide that features the exact dimensions for each part of the office versus hallway versus other components of the architectural structure. Teachers can vary the activity and the way they handle it with their students based on the information they provide. Listen as one group pays attention to precision by noticing the different types of units that have been used in this problem.
Group 1, you think you want a 7 by 10, and group 2 wants 11 by 11. So if you had this for each, because we know how many employees it's supposed to hold, 12,000, right? So find out the area that the person will be working in.
That's meters though. I need to find, we need to convert it to whatever.
Feet?
Yeah.
As students make the conversion between meters and feet, the teacher carefully monitors the class as they make that calculation and selects the team to present first, carefully sequencing based on a mistake that she noticed.
How many feet are in a square meter?
6.56
What'd you do there?
multiplied 3.28 by
3.28 times 3.28.
No, we squared. I squared mine.
we didn't square.
They multiplied it by 2.
They multiply by 2.
Yeah. So,
So-
it's 10.7584.
These practices help the teacher from randomly selecting students that might not lead to the desired outcome of the lesson. It's very important that the fifth practice, connecting the strategies and ideas in a way that helps students understand the mathematics that is the focus of the lesson, is pivotal in constructing and building student learning. Once students complete their investigation, you can follow up with a video that features the Apple Park as of February 2018. They can also follow up with the informational article from Wired.com that gives them more information about the finished office campus. The illustrative math task, how many cells are in the human body, as featured in the Georgia frameworks, might be another opportunity for your students to investigate the concept of density and volume. Based on the level of your students, you might simply give them the question along with the information on the radius of a cell and the approximate density of the cell. Other students might need more scaffold information, such as how do you find the volume of a sphere, and a reminder about the concept of density and its formula, along with the conversion factor that allows students to convert pounds to grams. Once students have investigated this task and made their estimation, you could have them visit the National Geographic site and read the article, How Many Cells Are in Your Body, to compare and contrast their answer to the actual answer.